It seems that the solar system has been studied inside and out. Our spaceships have visited all of its planets and even managed to take their pictures. But today, we'll show you our solar system in a completely new light. You'll discover secrets that haven't been revealed yet, hear eerie sounds coming from the solar system, see strange objects that frighten and amaze scientists, and even look inside the solar system's bodies. But let's start from the very beginning, the birth of the Sun and the planets orbiting it. It's interesting how early astronomers thought we were the center of the universe, that everything, including the Sun, revolved around the Earth. Now we have a much better picture of where we are in the cosmos and some ideas on how everything formed. Our solar system developed inside a structure estimated to be around 13.6 billion years old, a cosmic structure almost as old as the universe itself. The Milky Way galaxy is incredibly vast, with an estimated visible diameter of 100,000 to 200,000 light-years across, and could easily contain over 200 billion stars. This all sounds remarkable, and it is, but data also shows the Milky Way and its neighbors are residing in the outback of the cosmos. In fact, the Milky Way galaxy sits on one of the largest known voids in the universe. Now, let's take a closer look at where we are in this galaxy. This is the Orion Arm. It's a minor spiral arm of the Milky Way galaxy that's 3,500 light-years across and 10,000 light-years in length. If we zoom in on a small section of this arm, we find a yellow main sequence star in a place called the Orion Spur, which is a connecting structure between two larger arms. There's nothing special about this star. Its size is precisely the definition of one solar mass, and it's actually quite small compared to other stars. And for the record, about 90% of stars in the universe are main sequence stars, which fuse hydrogen atoms to form helium atoms in their cores. But there is one thing that makes it special. It's our star. Right now, we're all floating on a tiny blue marble called Earth. Around this star, we call the Sun, along with 7 other planets and countless smaller objects such as dwarf planets, asteroids, and comets. But how did this stuff in our solar system get made? Let's talk about the Sun for a minute. It's known as a population 1, or metal-rich star, with the highest metallicity out of the 3 populations of stars, and is the most commonly found star in the Milky Way. Star formation is a complicated process, and somewhat difficult to explain, but the nebula hypothesis is the most widely accepted model explaining the formation and the evolution of the solar system. The Sun formed some 4.6 billion years ago from a giant cloud of gas and dust rich in heavy elements. This vast cloud of hydrogen, silicates, iron, water, and other substances, called a solar nebula, began to spin and collapse under its own gravity. Some astronomers say this could have been triggered by the shockwave of a nearby supernova from an older population 3 star, which caused the solar nebula to spin and flatten into a disk the same way that galaxies form. Most of the nebula's material was pulled towards the center to form our Sun, which some astronomers say took around 100 million years. The big mind-blowing thing about all this is that the Sun accounts for a whopping 99.8% of our entire solar system's mass. Despite ancient astrological beliefs, the solar system is anchored by the Sun. This star began its life as a protostar, enshrouded in the solar nebula cloud, accreting more material and creating a protoplanetary disk. Collisions of gas and dust within this flattened disk concentrated the material into a thin, flat plane, and the tiny fraction of the remaining 0.2% of material was distributed at varying distances from the newborn Sun. Astronomers call this a protoplanetary disk, the place from where all planets are born around an evolving protostar. No one knows for sure how objects in our solar system came to be, and since the Sun's planets formed a long time ago, much of the evidence for exactly how this happened has been lost. But we think we have an idea of how it might have happened from studying neighboring stars and their planetary systems. As this very hot disk of leftover material from the creation of the Sun cooled, tiny particles began to collide and stick together, forming kilometer-sized planetesimals. Planet formation isn't entirely understood, But the accretion model shows that planetesimals grow larger initially by accreting pebble-sized objects until they reach their pebble isolation mass. When this mass is reached, accretion of gas onto the planetary core can start. Closer to the forming protostar, larger pieces continue to collide with each other, forming rocks, and then bigger objects by a process called runaway accretion, resulting in the rapid formation of moons and much larger planetary embryos. Once their gravitational influence grew, the planetary embryos went through a stage of violent merges, as clumps of rocks and ice continue to collide and accumulate, creating terrestrial planets near the star that are made of rock and various metals. These are the inner rocky planets we know of today in our solar system: Mercury, Venus, Earth, and Mars. As for the outer regions of our solar system, gas and dust were being pulled together to create 4 other celestial bodies. A couple of these new planets became ice giants due to their incredible distance from the Sun. We know these outer planets as Jupiter, Saturn, Uranus, and Neptune. There is a hypothesis of how the 2 big gas giants, Jupiter and Saturn, were formed. The big challenge is understanding how a solid planet grows large enough to capture gas. Astronomers believe planets first form as solid objects made of materials like rock, metal, and ice. If the planet becomes big enough, it can capture an atmosphere from the surrounding cloud of gas in which the planets are forming. For a planet like Earth or Mars, this atmosphere is relatively thin and makes up a small fraction of the planet's total mass. But larger planets like Jupiter and Saturn can gain thicker atmospheres and, above a certain mass, pull in more and more gas until something stops it. These 2 gas giants are made mostly of hydrogen and helium gases, and may have had a small rocky core in the beginning of their formation. Planetesimals that weren't big enough to accumulate enough material to form a planet become moons, asteroids, or comets. Other loose material around some gas giants became planetary rings. Thus, the solar system was born. But things were about to get more chaotic during its evolution. Our solar system once experienced a fiery meteor shower of apocalyptic proportions. Asteroids collided with the inner planets, keeping their surfaces hot and molten. Astronomers call this the Late Heavy Bombardment and think it could have happened around 4.48 billion years ago. Astronomers believe this bombardment was caused by the gas giants moving around and pulling lots of smaller objects towards them, and in turn flinging those objects at the smaller inner planets. While we're talking about these inner terrestrial worlds, it's worth mentioning that Earth stands out from the other planets because of its high water content, and there's a big debate about where this water came from. Now, when we look at the Earth from space, it looks like a giant globe of water with some land here and there. But if you took all the water on the planet and put it into a ball, this is what it would look like. The larger globe is all the water on, in, and above the Earth. The 2 smaller ones are liquid freshwater, and the smallest is freshwater lakes and rivers. When you look at it this way, it seems like a lot less water. However, it's a lot more water than other planets. But how did the Earth get its water in the first place? Researchers have found a rare type of meteorite called an estetite chondrite that has a similar isotopic composition to terrestrial rocks. No one knows where these rare meteorites formed, but their composition leads some to believe they formed closer to the Sun in the early solar system. They can be seen as the remnants of the planetary material that was present in the inner solar system. Upon further study of these meteorites, something unexpected was discovered. These estetite chondrite meteorites contain sufficient hydrogen to have delivered 3 times the amount of water in the Earth's oceans. Another hypothesis is that the Earth's water might have simply come from the nebular material from which the planet accreted. Despite this, we still have no idea where the Earth's water came from. The late heavy bombardment period could have caused some cataclysmic things to happen to other planets. Uranus is arguably the most mysterious planet in our solar system, simply because we don't know much about it. We've only visited the planet once with the Voyager 2 spacecraft. But there is a reason that we mention this mysterious planet during the birth of our solar system. The poles along which the Sun, Earth, and nearly all the planets in the solar system are pointed in the same direction. However, Uranus is the oddball in the solar system because its axis of spin is tilted by 98 degrees. Yes, Uranus spins on its side. So what could have happened to cause this? Some researchers running computer simulations believe a rock the size of the Earth slammed into Uranus and knocked it onto its side. The massive collision also created at least 9 of its 27 moons. The planet Neptune took shape when the rest of the solar system formed. Like the other planets, gravity pulled in, swirling gas and dust until it became the ice giant it is today. Like its neighbor Uranus, Neptune may have formed closer to the Sun and moved to the outer solar system about 4 billion years ago. But our solar system extends much further than the 8 planets that orbit the Sun. Just past Neptune's orbit lies the Kuiper Belt, a sparsely occupied ring of icy rocks that are almost all smaller than the popular dwarf planet Pluto. And there's even more. Out past the Kuiper Belt is the mysterious Oort cloud, which is a giant spherical shell of material that surrounds our solar system that's between 1,000 to 100,000 astronomical units thick. It's never been directly observed, but it's predicted to exist from data based on the mathematical models and observations of comets that likely originated from there. The Oort cloud is thought to be made up of trillions of pieces of icy space debris, with some pieces that are as big as mountains or bigger. This cloud of debris orbits the Sun as its boundary of gravitational influence about 1.6 light-years away. This means that some objects in the Oort cloud can turn around and move back towards the Sun, and those objects could possibly collide with planets on their way. While the Oort cloud is a hypothetical structure, the largest comet ever seen in history was recently spotted coming from this direction. Bernardinelli-Burstein is an icy rock with a nucleus blacker than coal that stretches 129 kilometers across. That's larger than the US state of Rhode Island and 100,000 times more massive than a typical comet. It's currently traveling towards us at 35,000 kilometers per hour and is supposed to reach us by the year 2031. But there's no need to worry. As NASA says, the closest it'll get to Earth is 1.6 billion kilometers. It's really mind-boggling to think about how the solar system formed and to know that everything began with our Sun, its formation triggered by the stellar winds of a supernova. But there's something else you probably don't know. Nearly all the elements in the human body were made in a star, and many of those elements came through several supernovas. When Carl Sagan said, "We are made of star stuff," he wasn't being metaphorical. Actually, it's 100% true. Maybe that's why humans have gazed up into the heavens for centuries, longing to travel to the stars and distant worlds, and in a sense, travel back to where we came from. Since we began exploring space, we've been looking farther out in the solar system to see what's there. And in 1992, we discovered the Kuiper Belt, an icy cold and dim region beyond Neptune's orbit. There have been a lot of interesting discoveries there recently, and some strange and mysterious objects have been found floating around in the belt, and one of these has scientists completely baffled. What are these objects, and is it possible one of them is an alien ship? Get ready to find out the answers to this and more. The Kuiper Belt has millions of strange objects in it. Some are 100 kilometers wide, and some are really huge, measuring 1,000 kilometers in diameter. So what are they? Kuiper Belt objects, or trans-Neptunian objects, are the remnants of the very birth of our solar system that happened about 4.5 billion years ago. It's a huge volume of space, as you can imagine. While we had just discovered a tiny fraction of this region, we've already found about 2,000 Kuiper Belt objects. However, some of them raise more questions than they give answers. In April 2016, the New Horizons probe reached the dark and mysterious Kuiper Belt. As the probe was moving past Pluto and nearing the belt, it discovered a weird object on a strange trajectory. It was given the name Aaron, and it was measured at 133 kilometers in diameter. While researchers were looking at it, it appeared to grow brighter and then dim in a precise rhythm, suggesting it was spinning. Most objects in the belt are made of ice and rock, but this thing seemed to be made of something different. Astronomers were right, but Aaron was spinning so fast, about once every 5.5 hours, that if it was made of ice and rock, it should have torn itself apart from the centrifugal force alone. But it didn't. Scientists started to wonder, what is it, and what's it made of? It was time to get in for a closer look, so NASA steered the New Horizons probe in its direction. But something weird happened as the probe approached Pluto on its way. Communications were suddenly lost, as if something was jamming its signal. And as the probe moved away from Aron, communications were again restored, which turned out to be a computer glitch. But NASA was prevented from finding out the truth about the intriguing spinning object. Some researchers suggested that the spinning is creating artificial gravity in the middle of Aron, and it could be some giant ship, something you may have seen in science fiction films. However, the gravity would not be enough for human passengers, but for some other form of alien life, it could be. Could this object be an interstellar alien craft of some kind, like Oumuamua is thought to be? Most likely not, but there is always a slim chance. If you were an alien species and you wanted to get a look at the strange creatures known as humans, the Kuiper Belt would be the perfect place to hide. Perhaps in the future, we'll get another chance to get close and figure out exactly what Aron is. Still, there are Kuiper Belt objects we know a lot about. In 2014, astronomers discovered a weird celestial body in the outer reaches of our solar system. Its estimated size was roughly 32 kilometers across, and what's truly interesting is its shape resembles a snowman. In fact, scientists have long struggled to understand how such a shape could have formed. The object was named Arrokoth and has been visited by the US space probe in 2019. It's become the most distant space object we ever examined at such a close distance. Arrokoth is an example of the most primitive object in the solar system, so you may think there's nothing interesting about it. However, for scientists, flying past Arrokoth was as thrilling as exploring Pluto up close. So what's so special about it? One theory suggests that our solar system formed from a dense cloud of space dust and gas. All that material, as gravity pulled it together, transformed into the planetary system we see today. There's just a tiny gap here. We don't know what happened in between these stages. And because the average Kuiper Belt temperature is about minus 370 degrees Fahrenheit or minus 220 degrees Celsius, KBOs are typically well preserved. So they can fill in those gaps, and Arrokoth is one of the missing puzzle pieces. In studying this weird-shaped flat object, scientists came closer to uncovering how space bodies in our solar system were formed. Arrokoth is a contact binary object, meaning it consists of two parts stuck together. And since these lobes differ in color, it could indicate they have once been separate objects that formed from dust in the primordial cloud over 4 billion years ago. But how did they come together without seriously damaging each other? It turns out collisions that took place billions of years ago weren't that fast and violent. In the case of this KBO, gravity made the two separate parts slowly rotate around each other and bind together in a slight collision. Each celestial body has an intriguing formation story, and if you'd like to see a video about the birth of our sun and our solar system, let us know in the comments. Still, Arrokoth isn't the only mind-boggling object the Kuiper Belt has to offer. The next object isn't famous for its size at 650 kilometers or its shape or color. But what's strange is this object's density that's 18% less than that of water, which means it can easily float. The object has the name 2002 UX-25, and its low density is a big mystery. One way to explain it is the celestial body's high porosity or gaps in its structure. However, it's commonly seen in objects less than 350 kilometers in diameter. Larger objects are too massive for such a low porosity because the force of gravity compresses their material, leaving no room for these gaps. Is this Kuiper Belt object a forensic oddity, something that will change planetary formation theories, or is it something more complicated? Whatever the reason, we've got to learn more about average-sized KBO's density to define it for sure. Another intriguing object is almost 4 times the size of UX-25, and it's got a lot of stories attached to it. This one's a planetoid, a minor planet that consists of rock and ice, and it's about 1,300 kilometers wide, but scientists speculate it should have been twice its size sometime in the past. It's possible that this KBO had a collision with Pluto and lost its material as a result. What astronomers cannot wrap their heads around is why this object's temperature has risen from about minus 360 degrees Fahrenheit to minus 260 degrees Fahrenheit millions of years ago. Did something or someone heat it up? We don't know yet. The Kuiper Belt object is called Quaoar, and throughout the last several years, scientists have found water ice present on its surface. What's more, there could have been an ocean on this planetoid in the past, and that's not all we know about Quaoar. It also has a bright surface, which could indicate the KBO may have had geological activity, such as cryovolcanoes not so long ago. We all know what volcanoes are, but cryovolcanoes are something different, although they both act similarly. The one with the weird name erupts ice chunks, water, methane and ammonia instead of magma and ash. Quite a breathtaking view, as you can imagine, and we could probably witness this phenomenon in the future, but there's no planned mission to Quaoar yet. But if there will be one, we'll make sure to tell you about it. There's also an intriguing space body outside the Kuiper Belt, but it's still worth mentioning. Once astronomers had discovered and observed it, the object raised tons of questions. One of them was about its mysterious composition. We're used to thinking that the majority of space bodies outside our solar system are made of ice. As a result, they're usually either white or grey. However, what we see with this object is quite different, because it's nearly as red as Mars. Another mystery is how oddly this space body moves. Its orbit isn't like anything we've seen before. It's called Sedna, and it moves as close as 11 billion kilometers to the center of our solar system. Then Sedna drifts away to about 135 billion kilometers. It's such a great distance that it needs roughly 11,000 years to make a full circle. Sedna, along with other celestial bodies, is thought to be a part of a collective gravity. When space objects orbit another object, like a binary star, they pull and push on each other, and it affects their orbits. One mind-blowing suggestion is that Sedna and a few other space objects could have been the reason for the extinction of the dinosaurs. As the orbit of these objects fluctuates, they can shoot nearby comets into the solar system and even towards Earth. Since Sedna swings back and forth so far, it seems there's some unforeseen force that pulls on Sedna. And the force is the hypothetical Planet 9, located far beyond the Kuiper Belt. It's estimated to be about 5 to 6 times the size of our planet. Although it hasn't been found yet, there's the theory it could be an alien imposter that came from a different star system. Other scientists suggest it's an ancient black hole. Whatever the case is, Planet 9 is supposedly hiding somewhere in our solar system, and it's hard to detect because of the bright row of stars in our Milky Way. However, a recent study suggests it may be closer and brighter than we think, and if it's brighter, it can be easier detected. If found, we could stumble upon a mega-Earth or a mini-Neptune. So how do we find it? Well, scientists are currently using different telescopes to scan the section of the sky where Planet 9 could be. Their best shot, however, will be the Vera Rubin Observatory, equipped with a powerful 8.4-meter telescope. When completed in 2023, the telescope will be repeatedly scanning about 2/3 of the sky, looking for everything from asteroids to the mysterious Planet 9. If we discover it one day, it'll become the first time a planet is found in the last 200 years. There are also quite bigger trans-Neptunian objects out there, and some of them are so big they're called dwarf planets. One of the biggest Kuiper Belt objects ever discovered is also the 25th largest body in the solar system, and there are hundreds of thousands of space objects in it. Although this TNO is nearly 46 astronomical units from us, it's the brightest object in the Kuiper Belt after Pluto. In fact, the object's big size was one of the reasons Pluto was reclassified as a dwarf planet. This Kuiper Belt object is called Makemake, and scientists will struggle to answer why it is bright while its moon, MK2, is as black as charcoal. What's also weird is they expected it to have an atmosphere, but it doesn't have one. All we know is it's quite cold, about minus 400 degrees Fahrenheit or minus 240 degrees Celsius, and these two factors make life impossible there. So far, there are no planned flyby missions to Makemake. Nearly every object we found in the Kuiper Belt has its mysteries, and the next one has got a couple of them. This dwarf planet is known for its strange shape, 2 moons, and an odd rotation. Plus, this is the most distant space body that has rings around it. and we don't know why. The object's name is Haumea, and it's the third closest dwarf planet to our star. The weird shape of this KBO resembles a rugby ball. Similar to how you throw a balloon filled with water and it kind of flattens, this object's elongated shape was created as it was spinning through space. As a result, Haumea's day lasts only 3.9 Earth hours, which is also one of the shortest days in the entire solar system. If you lived on Haumea for 1 year, 1 day equals 4 hours, and comparing that to a 24-hour Earth day, you'd be 283 years old back on Earth. While most of this object is rock, its outer layer is thought to be covered with ice, the same ice you find when you open your freezer. However, there's also a weird red spot on its surface that may be rich in minerals, but we're not sure about the origin of this spot just yet. Perhaps it could be something quite different from what scientists are thinking, maybe even a sign of extraterrestrial life. Given how many new things we discover in space, it's possible that we might find alien technology one day. The Galileo project, launched in 2021, is going to try and find alien artifacts in space and here on Earth. And while the chances of finding something significant are small, it could become the breakthrough we've been waiting for since the launch of the first space rocket. Even if the project fails to detect such signs, it could still find eye-opening explanations for Oumuamua and UFOs. The project team claimed it would make all discoveries publicly available. So stay tuned, as we'll definitely let you know about them once they come. As we learn new things about something, we start to believe we know a lot about it. But this isn't often the case with space. Our solar system is much, much bigger than you'd expect, and you'd be surprised how little we know about it. But soon, with the launch of a next-generation telescope, that might change. Does this mean we would finally detect an elusive Planet 9? Will we find some other secrets our solar system has stored for us? And would it all change the way we perceive our place in the cosmos? Now, get ready to discover answers to this and more. Referred to as Planet 9, but sometimes referred to as Planet X before Pluto's reclassification, this is an elusive world orbiting far beyond Neptune. It's been a mystery for scientists for decades. Since the beginning of the 20th century, astronomers suspected the existence of a large body affecting Uranus and Neptune. But once Voyager 2 approached Neptune in 1989 and sent us back data, it became clear we had wrong calculations. It turned out there was nothing weird about the two gas giants. It looked as though the hunt for Planet X came up empty. But that wasn't the end. Just recently, one curious scientist decided to look through the 38-year-old data from the Infrared Astronomical Satellite, the very first telescope that managed to scan about 96% of the night sky. And among about 250,000 point sources, there were 3 specifically interesting ones. But how do you look for something in our solar system? If you take a telescope and look in a specific direction of the night sky, you'll see a bunch of dots. Some of those are distant stars, and some are solar system objects. So how do you distinguish one from the other? You look at an object's motion. If it barely moves or doesn't move whatsoever, the chances are it's located quite far. But if an object travels a significant distance in space within a relatively short period of time, it means it's close enough in our solar system. Only 1 out of 3 objects from the IRAS data that met astronomers' requirements was captured moving through space. This is when the scientific community became thrilled. If the IRAS data is right, a planet we've been looking for should be 3 to 5 times as massive as Earth and orbit at a distance of approximately 225 astronomical units, 1 AU being the distance from Earth to the Sun, which is 149,597,870.7 kilometers. But the other 2 scientists involved in the search didn't agree with that conclusion. However, they found yet another theory of Planet 9's existence, and once again, the search got a new course. On the outskirts of our solar system lie 6 space bodies called extreme trans-Neptunian objects. And they aren't just some random objects. They all have one thing in common that makes scientists curious. All 6 of them have an orbit pointing in one direction. And because the chances of such distant space bodies with such an alignment are roughly 0.007%, we know there's something causing it. a gravitational influence of a much larger body somewhere out there. All the strange phenomena could be explained by a planet 2 to 4 times the radius of the Earth, and almost as massive as Neptune. It would also have a highly eccentric orbit, getting close to our Sun at about 200 AU, and then moving away at a mind-blowing 1,200 AU. Such an elongated orbit would have a 20,000-year orbital period. The only thing scientists lacked to make their theory look promising was several objects with even stranger elongated orbits. But as it turns out, another astronomer has just discovered such objects exactly where this theory would predict them to be. Still, knowing Planet 9's orbit doesn't tell you where on its orbit it currently is. Nevertheless, there are things that scientists know for sure, and by means of pure logic and mathematics, they could make predictions on where to look for it. For example, at its nearest point to the Sun, Planet 9 has a brightness of 18th magnitude, so if it recently was that close to us on its orbit, it would have been easily spotted. And because of that, we think it's closer to its furthest point, where it's as faint as 25th magnitude, which makes it harder to notice. How bright is that? The smaller the number, the brighter the object. To compare, Pluto's average magnitude is approximately 15. Thankfully, 25th magnitude is still in the range of what the Hubble Space Telescope is able to detect. This is 10 billion times fainter than the human eyes can see. So, while we don't know for sure where it is, we have decent proof to think it's there. You may think it's impossible to find such a distant object given the data we have, but we've already found a planet based on our predictions once, Neptune. Astronomers of the past believed something was tugging Uranus, but they couldn't find any reasonable explanation. Later, one scientist, using classical celestial mechanics, made a prediction on the location of a hypothetical planet that was supposed to be in charge of what was happening to Uranus. Using those calculations, astronomers were able to locate Neptune exactly where it was predicted to be in just one night. But while Neptune orbits our Sun at about 30 astronomical units, Planet 9 is expected to be much further away. Because of the great distances and how dim Planet 9 is, our chances aren't that high. But that could change very soon. A new generation of telescopes are on their way, and one of them is currently being built in Chile. Scheduled to begin operations in the fall of 2023, this is going to be an 8.4-meter telescope with a 3200 megapixel camera on board. The camera, the size of a car, is going to be the largest camera constructed for astronomical purposes. With such a tool, scientists could not only verify if Planet 9 actually exists, but also find roughly 20 terabytes worth of space objects and other phenomena in one night. Just in a year, the observatory will be able to capture more of the cosmos than all the telescopes on Earth ever did combined. This can turn our perception of the universe and our place within it upside down. If you'd like to see a full video about this telescope and what it could find, make sure to let us know. But what if we scan every point of the sky where Planet 9 could be and find nothing? Well, there's an idea that Planet 9 could be mistaken for a primordial black hole that would cause similar gravitational effects. Although it's purely hypothetical as we haven't detected one yet, at the very dawn of the universe, when everything was much denser and hotter, primordial black holes popped in and out of existence within just a second, and depending on when during that second such a black hole was born, its mass could have been as little as 5 to 10 grams, or as enormous as 100,000 solar masses. The thing is, if our calculations about an elusive planet's mass are correct, a primordial black hole a few times the mass of Earth would only be the size of a grapefruit, or even smaller than a human fist. And if that's the case, we've no chance of finding it with a telescope, ever. Although we may just detect it with the more aggressive method. The idea is to send hundreds or even thousands of small laser-propelled spacecraft and test the gravitational field of a possible primordial black hole. Even if just a few of these tiny spacecraft pass a black hole at a distance of tens of astronomical units and sends us back data, it would be enough. But how would we know if we were right? We could figure out if a black hole is really out there by measuring intervals between those signals. If it's there, the signals will lengthen under the gravitational influence of this mysterious object. Yes, Planet 9 has a lot of theories surrounding it, and even that isn't the last one. After all, Planet 9 could have once been a rogue planet, or such that was freely wandering through space without a stable orbit. and sometime in the past it could have been captured by our star's gravity. That may seem unintuitive to you, but some studies show that in our galaxy there are more planets unattached to a star than those orbiting one. What's interesting is that, according to simulations, in 60% of cases, rogue planets just enter a solar system and leave it. But in 1 out of 10 cases, such a planet could take another planet with it on its way out. But there's also a 40% chance that a rogue planet won't be able to escape a solar system once it enters it. That is one possibility of what Planet 9 could be. Besides, we've already discovered some rogue planets in the past. Looking for such worlds is no easy task. A rogue planet, a star behind it, and an observer should be aligned almost perfectly. And the only way we know if it's there is if gravity bends the light emitted by a star behind it when a planet flies past it. 2 such events with perplexing names became promising rogue planet candidates. One of them is suggested to have a mass range between Neptune and Earth, while the other one could be as massive as Jupiter or even as a brown dwarf. Not so long ago, the Kepler Space Telescope possibly detected 4 new Earth-sized rogue planets wandering through our Milky Way. So far, we don't know much about rogue planets, but what's interesting is that some scientists think they can actually be habitable. But how could a planet that doesn't get enough light sustain life? Well, there are 3 possible scenarios: subsurface oceans, tidal heat, and an active galactic core. The odds for life on the surface of such space objects are close to 0. That's true. Subsurface oceans, on the other hand, could not only host microbes, but something bigger as well. A rogue planet's interior, or its highly dense hydrogen atmosphere, would trap some heat and prevent these oceans from freezing. Even within our solar system lies a frozen object that has liquid water on it, Europa, Jupiter's moon. A massive moon surrounding such a planet could also cause tidal heating. Under the right circumstances, if a smaller celestial body orbits a much larger one at close distance, the gravitational pull of a larger body would distort the shape of a smaller one, and, similar to the way a piece of wire heats when you bend it, it would heat that object. A rogue planet traveling through space near an active galactic nucleus would also be able to get enough light from the center of a galaxy. And as long as a rogue planet stays within 1,000 light-years from the galactic core, it could even sustain photosynthesis. Our solar system is a strange place, with its 4 giant worlds and 4 smaller planets. To scientists, this looks odd, as if something was missing. And what are the chances that astronomers working centuries apart repeatedly come to the exact same conclusion? There is something there. Well, far, far out, the most distant object ever found by a human being in our solar system is just some 130 AU away. Add another 1000 AU to that number and you arrive at the farthest point of Planet 9's orbit. So there's still a long way till we master our searching abilities, but hopefully Vera Rubin Observatory will be a huge step towards finding out more about the mysterious place we live in. At the farthest reaches of the solar system lie the ice giants Uranus and Neptune. Their calm-looking blue atmospheres, huge ominous storms, delicate sets of encircling rings, and moons with icy terrain hold many unsolved mysteries. NASA's Voyager 2 is the only spacecraft to have visited these 2 planets in the 1980s, but the visits were very short. But now, scientists have learned some really amazing things about both these planets, and something is probably happening on their surface that you won't believe. There's 4 gas giants out there in our solar system, but unlike Jupiter and Saturn, Uranus and Neptune are rich in water. Most of that water is in the form of ice, and now new studies found there may also be oceans under their icy layers. But that's not all. Researchers now say these oceans could be rich in magnesium, but these oceans might be made of something else entirely, and we'll get to that soon. We need to mention that even though Uranus and Neptune are considered gas planets, they're also called ice giants because of their rocky, icy cores, which are much larger than the amount of gas they hold. But some strange things have been discovered lately, and researchers have been trying to figure out what is happening on the surface of these 2 ice giants. Not only that, but some have wondered what it might be like if you tried to land on any so-called surface of Neptune and Uranus. You may have also heard that it could actually rain diamonds on these planets, and now some researchers believe that both Uranus and Neptune could have oceans of liquid diamonds. Now that sounds wild. But how is this possible? Keep that in mind, because we're going to get to that in a couple of minutes. But first, let's take a look at each of these planets, and we'll tell you the most incredible things that have been discovered up to now. You have to admit that Uranus is a bit of a sad and lonely world, one that's tired of being the butt of many bad jokes, including that one. However, its name is actually a reference to the Greek god of the sky. This freezing world was the first planet ever discovered using a telescope in 1781 by William Herschel, and is about 2.9 billion kilometers from the Sun. Voyager 2 got as close as 80,000 kilometers from the planet and captured only a handful of images. But those images had astronomers thinking it's possible that something really big crashed into Uranus in the early days of the solar system, not once, but twice. The result of these two big impacts left the planet rotating on its side. This means it's orbiting the Sun like a rolling ball, which, by the way, takes 84 Earth years to go around once. Uranus has 27 moons, and they could have formed from these big collisions that put the planet on its side. Also, its magnetic north and south are way different from its polar north and south. Because of this, there are some really bizarre seasonal effects. Imagine a planet that has its south pole pointing at the Sun, while the north pole is shrouded in complete darkness for 21 years. In 2011, telescopes showed something strange happening on the planet. A big fuzzy white spot appeared on its frigid blue cloud tops, and astronomers claimed it was a giant methane storm. In fact, some of these storms have been spotted by the Hubble telescope. Huge storms, half or more the size of the entire USA. The average temperature in the methane and ammonia clouds is minus 128 degrees Celsius. Winds on the planet can reach up to 144 kilometers per hour. And by the way, Saturn isn't the only planet in the solar system to have rings around it. Uranus has two sets of rings, both orbiting above its equator. But its icy twin Neptune is even farther away from the Sun, some 4.5 billion kilometers away, and it takes 165 years to orbit the Sun. Voyager 2 was able to get as close as 4,828 kilometers to Neptune, which appears to be made up mostly of ices and rock, and could possibly have a rock-ice core about 1.2 times the size of the Earth, and around 10 times the Earth's mass. Its atmosphere is made up of 3/4 hydrogen and 1/4 helium, with a small amount of methane that produces clouds. The bluish color of the planet is from light scattering and red wavelength absorption by the methane in its atmosphere. Like Jupiter's giant iconic red eye, Neptune also has a huge dark vortex, an anticyclonic storm called the Great Dark Spot that's 11,000 kilometers across, almost as big as the Earth, and it's racing across Neptune at 1,100 kilometers per hour. But that's not all. In fact, Neptune has the most ferocious and fastest planetary winds in the entire solar system, reaching 2,000 kilometers per hour. Definitely no place for a holiday. The energy for those high-speed winds is not coming from the Sun, but what might actually be happening closer to the core of the planet. In fact, Neptune appears to have some kind of internal heat source and radiates twice as much energy as it gets from the Sun. And even though it's farther away from the Sun than Uranus, it's a bit warmer, thanks to Neptune's atmosphere, which is probably holding in heat from its hot core. Now, both of these planets have unstable and strange magnetic fields that are strongly tilted relative to each planet's rotation axis, and are significantly offset from the physical center of each planet. It's been a long mystery for some time now, and no one's sure why these magnetic fields act so strange. The magnetic field on Neptune is 27 times more powerful than that of the Earth, while Uranus only has a magnetic field 1/3 as strong as the Earth, and we'll explain in a minute what scientists think is causing the magnetic fields to act strange. Even though it might seem really cold on both of these worlds, and the magnetic fields are bizarre, intense heat and pressure thousands of kilometers below the surface of each planet may tell a different story. The atmospheres of both planets are primarily made up of hydrogen and helium, with small amounts of methane. Below these atmospheric layers is a super hot, super dense fluid of icy materials like water, methane, and ammonia that wrap around the planet's core. Because of this, astronomers studying these two ice giants have come to the conclusion that it could be raining diamonds closer to the surface of each planet. This is possible because deep inside both these ice giants, pressure and heat builds until gaseous hydrogen turns into liquid metallic hydrogen, Methane in the atmosphere decomposes, and as the bonds holding methane's 4 hydrogen atoms dissolve, the carbon atoms left over bind to one another under extreme pressure to form diamonds. At its core, Neptune reaches temperatures of up to 7,273 Kelvin, which is comparable to the Sun, while the core of Uranus heats up to 9,000 degrees Fahrenheit. Yes, it could actually be raining diamonds closer to each planet's core. But not only that, it's also possible that there are oceans of liquid diamonds beneath the surface of the 2 ice giants. Research was done by taking detailed measurements of the melting point of diamond. When diamond is melted, it behaves like water during freezing and melting, with solid forms floating atop liquid forms. Obviously, diamond is a very hard material, making it really hard to melt. And measuring the melting point of a diamond is also very difficult, because when it's heated to very high temperatures, diamond changes to graphite. But it's diamond that turns into a liquid, not graphite. So what scientists did to get around this problem is expose the diamond to extremely high pressures by blasting it with lasers. Diamond is liquefied at pressures 40 million times greater than found at Earth's sea level. When the pressure is lowered to 11 million times greater than the Earth's sea level, chunks of diamond start to appear. But something happened that scientists didn't expect. The chunks of diamond didn't sink, but floated on top of the liquid diamond layer, creating diamond icebergs. These are the same ultra-high temperatures and ultra-high pressures found on both Uranus and Neptune. Both planets are estimated to be made up of 10% carbon, so a large ocean of liquid diamond could deflect or tilt the magnetic field out of alignment with the rotation of the planet, which could explain the strange magnetic field behavior. Is it possible that both planets rain diamonds and have vast oceans of liquid diamond? Only by sending a spacecraft there will we find out. Now researchers and scientists are trying to get NASA to send a spacecraft to these 2 worlds in order to study them. But the planets will be closest to the Earth soon, and astronomers say that a spacecraft would need to be launched by 2030 in order to take advantage of Jupiter's gravity and slingshot the spacecraft towards these ice giants to arrive in the mid-2040s. In April 2021, astronomers spotted X-rays coming from Uranus using the Chandra X-ray Observatory. This revealed some unknown dimension of the colorful ice planet. This means that X-ray emissions have been detected on every planet in our solar system now, except for Neptune. In case you're wondering, there are 3 ways a planet can produce X-rays: fluorescence, scattering of solar X-rays, and emissions from auroras. Uranus is scattering the sun's X-rays, and X-rays are also being created by energetic electrons or protons, which collide with the rings, causing them to glow in X-rays. It's pretty much the same thing that causes Earth's beautiful and amazing auroras. We've landed probes and astronauts on the moon many times, and it seems like there wasn't much left to discover, but it seems the moon has a few surprises for us. And while we've studied our solar system and considered interstellar journeys, it looks like we've overlooked a lot of valuable data concerning our next-door neighbor in space. It turns out we don't know as much about the moon as we thought. Who would have thought our moon is like a disco ball? That's right. Scientists are trying to figure out the source of some strange lights spotted by the Earth's telescopes. Are aliens building a base there and sending us signals? Or is there something even more bizarre happening up there? You're about to find out. Even though the moon is about 4.4 billion years old and shows no signs of life, it's not completely dead. In fact, the moon is still active in some sense. Throughout the last 2 centuries, people have been noticing a kind of peculiar flickering on its surface. This occurrence was named the Transient Lunar Phenomenon, or TLPs for short. This weird flashing on the moon was first scientifically confirmed in 1958. According to observers, these optical flashes come in different colors, like red, blue, violet, and different shades. TLPs usually last around a second or 2 until they fade away. But there's also data showing long-term light bursts. Some of them were discovered to last from several minutes to a few hours. But the duration of these light events isn't the only thing that intrigues many observers. Their size is another interesting aspect. Some TLPs can range from a few miles to a couple of 100 miles in diameter. This fact significantly deepens the mystery around the source of these optical flashes, and they're not a rare occurrence either. In fact, the data collected by a UK-based researcher revealed around 3,000 TLP reports. but many of these reports might have been sent in by inexperienced astronomers. As the years passed by, modern astronomers equipped with advanced telescopes kept noticing the blinking on the moon. Later, the European Space Agency decided to study this phenomenon. The agency's Neliotta telescope showed something surprising. There's a lot more TLP events going on there. Another intriguing fact is that these sparkles have been spotted in different places across the moon's surface, but often occur in places like the Aristarchus crater. So what do scientists think is causing these mysterious flashes of light? Is it aliens? Well, there's no single explanation, and because there could be multiple reasons for why they happen, understanding the true origin behind TLPs becomes challenging. The simplest explanation for this phenomenon is meteorite strikes that generate bright flashes as they collide with the moon. Lunar outgassing is yet another reason. Now, outgassing simply means gas is leaking from the interior of the moon, and this process can be caused by different events. Much like how the moon's gravity causes tides on the Earth, our planet does something similar in return. The Earth weighs 81 times more than the moon, and that means it has a greater gravitational pull. Because of this, tidal forces can raise the lunar surface as much as 49 inches and cause rocks on the moon to fracture. And as the surface of the moon moves, gases from inside escape and form clouds that reflect sunlight. But since satellites, airplanes, and atmospheric phenomena such as light pillars and halos created when light is reflected or refracted by ice crystals in the atmosphere can also be seen by Earth-based telescopes, these can be confused with the moon blinking, and it only adds to the mystery. That's why scientists plan on studying these luminous events more closely. Recently, astronomers came up with an idea to use a new telescope system that will consist of 2 telescope tubes on a single mount, and both of these tubes will be equipped with cameras operated by 2 different computers. So as these telescopes watch the moon and record any TLPs, the computers, powered by artificial intelligence, will analyze the information received. Given massive amounts of data, the software will learn to differentiate TLPs from any other objects getting in the way of the telescope's lenses. It seems the Earth and the Moon have some things in common, and some of these things are more similar than you could ever imagine. While we're all familiar with earthquakes, most of us have never heard about moonquakes, and they're a real thing. See, as the Moon's interior continues to cool down after its formation, its surface shrinks. As a result, the Moon gets wrinkles, but since its surface is so fragile, it breaks, creating fault scarps, an offset or step caused by the fault slipping. This is somewhat similar to the way a grape turns into a raisin. In fact, over the course of a few 100 million years, our moon became roughly 150 feet skinnier. This whole process often leads to moonquakes. According to scientists, moonquakes caused by these faults can be quite strong, up to 5.5 on the Richter scale. An earthquake of such magnitude is capable of damaging old buildings and other weak structures. But while earthquakes usually last about a minute or less, moonquakes can last 20 times longer. There are quite a few phenomena on the moon that can threaten anyone who visits it. And because NASA still wants to send astronauts there, and even colonize the moon, we have to learn more about its environment before doing that. One of the challenges would be creating a habitat with super flexible materials able to withstand the recurring shaking. Despite many dangerous phenomena, the moon is also known to produce some harmless occurrences, and this one's actually quite interesting to observe. We all know what rainbows are, but what if we told you the moon can create rainbows just like the sun? Moonbows are rarely occurring nighttime phenomena that can be seen on Earth. The mechanism is identical to that of a rainbow formation, but instead of sunlight, it's the moonlight that bends and reflects off of the water. And as the light bends for the second time, the white light splits into shorter blue and violet and longer red wavelengths. Simply put, it's the angle of the light that makes rainbows colorful. But since moonlight is less intense, about 400,000 times darker than sunlight, moonbows' colors are much dimmer. They're often too dim to be detected by human eyes. and if you should spot a moonbow, you'd see it in a more whitish palette of colors. That being said, lunar rainbows are quite difficult to spot, and there are a few reasons for this. They can only be generated if the moon is quite low in the sky, almost near the horizon. Plus, the moon has to be full, and the sky needs to be clear and pretty dark. Also, you've got to be facing a waterfall or mist while standing with your back to the moon. Still, if you ever decide to try and observe this phenomenon, California's Yosemite National Park, Cumberland Falls, and Victoria Falls would be some of the best places to capture this. Now, moonbows are quite spectacular, if you get lucky and see one. But there's another similar eye-grabbing phenomenon called lunar halos, and you don't have to go anywhere to witness them. Also known as a moon ring, a circle around the moon is formed in cirrus clouds. What's interesting about these clouds is their high concentration of hexagon-shaped ice crystals that moonlight goes through and refracts off. But unlike these easily observable events, the moon's got other secrets that are much harder to detect. It wasn't long ago that scientists discovered a massive object buried under the moon's surface. The moon's South Pole Aitken is the largest known impact basin in the entire solar system, and when researchers studied the basin's crust, they noticed an underground mass that shouldn't have been there. It was a huge blob with a metallic core found at a depth of about 180 miles. Once scientists did their math, they concluded that this thing's mass was roughly 4.8 quintillion pounds, which is the same as 6 billion Empire State Buildings, and it made the crater's floor sink about half a mile. So where did that blob come from? Well, the most common answer is the moon had a big collision with an asteroid, and since the crater's diameter is a little more than 1,500 miles, you can imagine how big that asteroid was. Other scientists believe the blob was formed during the cooling phase when there was still liquid magma on the moon's surface. The basin has long been grabbing the attention of the scientific community, and the curiosity is growing. There are already several missions planned to the crater, and the nearby South Pole as the latter is known to be rich in valuable resources. One of them is access to sunlight that allows for solar power usage. Another one is water, frozen water to be precise. All this represents precious room for experiments once we get there. It looks like space is an abandoned, empty place without the slightest sign of another civilization like us. But does this mean the universe is absolutely silent and nobody except us has tried to explore it? Scientists' recent discoveries may prove otherwise. The farthest space probe, Voyager 1, has been traveling for almost 44 years now and still sends back data to Earth. And one day, scientists heard a shockingly strange cosmic hum. Even though the probe has already sent similar recordings in the past, the newly discovered signal was significantly different. For the first time in human history, we got the chance to explore what's hiding outside our solar system. The signal was found more than 14 billion miles from Earth. It was a sound that remained steady at 3 kHz for almost 3 years in a row. This has become the most stable and long-lasting hum ever detected by Voyager 1, and scientists were only able to discover it once the spacecraft got far enough. But where did this mystical sound come from? Most scientists believe the hum is a result of the plasma waves traveling somewhere in the depths of the universe. Now, plasma is a sort of major building material that nearly all cosmic objects consist of and emit. What's truly mind-blowing is that this sound stayed nearly the same, even after the probe flew for another billion miles. Such a level of consistency prompted other scientists to think there may be some source of energy causing this hum that we don't know about yet. But how is that possible if there's no sound in space? Well, it's true that sound fades away too fast in the vacuum of space since there aren't enough particles there for it to travel through. Even such sounds as black hole collisions or massive explosions of supernovas don't stand a chance. Here's a quick experiment. Put a tiny bell into a plastic bottle and screw the cap on. Now shake the bottle and listen to the bell. Now take off the lid, put 2 burning matches inside, and quickly put the lid back on so they burn out. Once the air in the bottle cools, shake it again. Notice how the sound is quieter or is not there at all. Nevertheless, there are different electromagnetic waves that travel through a vacuum without problems, and radio waves are one of them. Although our human ears cannot spot such signals, scientists found a way to convert them into sounds, and now we can hear the message Voyager 1 sent us. So, how did Voyager 1 manage to gather such faint signals and send this data to Earth? Well, the spacecraft was designed with two hypersensitive antennas designed to detect plasma variations in space and record them. But even using radio signals for communication that travel at the speed of light, more than 20 hours have to pass to cover such a distance. The sad truth is that soon we won't receive any signal from Voyager 1. According to scientists, it's currently running out of power, so the probe's crucial instrument may function for 3 or 4 more years. Voyager has already done more than we've ever expected, and it could still surprise us with more life-changing discoveries throughout the following years. Even though the latest probe's finding is kind of a big deal, NASA has previously discovered some other weird sounds that puzzled scientists. In 2007, researchers unexpectedly came across something bizarre stored in a few years old data. What they revealed were so-called FRBs, fast radio bursts. These are so quick that each burst only lasts about a millisecond. From this point, researchers have started searching for other possible FRBs, and they found tons of them. This is how these radio bursts sound. So far, it seems the more we find out about the universe, the more questions there arise. Could it be an attempt of an intelligent alien civilization reaching out to us? Or maybe this wasn't intended for our eyes and ears. Who knows? The majority of astrophysicists think these FRBs either come from black holes or massive neutron stars, probably the smallest yet some of the heaviest and densest stars out there. Other professors had a more thrilling idea of what was actually happening. Their theory is that these were powerful, misaimed alien radio signals that were intended to charge their light-driven cosmic ships at huge distances. What both sides do agree on is that these FRBs must come from an unimaginably distant source somewhere billions and billions of light years away from our galaxy. And while our technologies are limited to look that far, we seem to have harnessed our own solar system quite well compared to interstellar space. And NASA occasionally notices spooky sounds way closer within our planetary system. Let's take a look at Jupiter's moon, Ganymede. Here's the disturbing sound it makes. The reality is that these sounds are as a result of chorus waves, coherent electromagnetic waves. Now, these waves frequently cause auroras or polar light, and the Earth is not the only place you can see those. This breathtaking phenomenon happens on Saturn, Jupiter, and Ganymede as well. So, what you've just listened to could be basically a converted sound of polar lights on Ganymede. What about Mars, though? We've been studying it for quite a bit already, and NASA's Perseverance rover has just come across something fascinating. The first actual sound of the rover driving over Mars has been recorded. But what's interesting about it? Well, along with the noise of the metal wheels rolling on a rocky planet surface, Perseverance has captured an unidentified, high-pitched scratching sound. Here's the actual recording sent by Perseverance. Nobody knows what the cause of this scratching noise is, and while NASA's scientists try to get a clue, the mystery remains unsolved and leaves room for imagination. Scientific and technological progress do not stand still. In 2030, a prospective interstellar probe mission may take place. Scientists say this could be just as revolutionary as the very first attempt to land on the moon. Just imagine the largest rocket flying the highest possible speed to get 10 times farther than Voyager 1 got at the bare minimum. An expected lifespan for such a spacecraft is 50+ years, but given Voyager's success and today's advanced technologies, everybody hopes to see this number rise. This would be humanity's first significant step into the realm of stars. The mission's primary objective is to capture our entire solar system from a huge distance and continue with the exploration of interstellar space. Once done, we will finally get closer to defining our place in the universe and unraveling the mystery of deep space. Our solar system isn't silent. It's full of an unearthly cacophony of noises such as planets, plasma waves, electromagnetic disturbances, and charged particle fluxes. If you've ever wondered what the Sun or other objects in our system might sound like, then get ready to go on a ride and listen to the eerie, real-life sounds of the solar system. What you just heard is the heartbeat of the Sun, captured by NASA's Solar Heliospheric Observatory. 20 years worth of data reveal a low pulsing hum, and this sample has many frequencies of low vibrations mixed together. It's an eerie sound, but it might be sounds recorded by the Parker Solar Probe orbiting the Sun that are the spookiest. That was the sound of plasma within the solar wind from the Sun. Right now, there's a spacecraft out there named Bepi Colombo, which is on a mission to explore the scorched rocky planet closest to the Sun. And as it swooped past the planet, it picked up magnetic and accelerometer data and converted that into sounds you just heard. The faint sound you just heard is coming from the solar wind interacting with Venus, and was also recorded by the spacecraft Bepi Colombo as it whizzed by on its way to Mercury. You can hear the sudden bow shock crossing towards the end of the sample very clearly. But it's not the only sounds we have from Venus. On March the 5th, 1982, the Soviet Union landed a probe on the surface of Venus, and it was equipped with microphones. And this is what it sounds like on the surface of the planet. We all know what it sounds like on the surface of Earth, but what does our planet sound like from space? That was the sound of the Earth's magnetic field as recorded by the Italian Spring Accelerometer on board the Bepi Colombo spacecraft in 2021. The recorded accelerations measured by the spacecraft were translated into a frequency that's audible to the human ear. The European Space Agency's Cluster Mission spacecraft recorded what the Earth's magnetic field sounds like when a solar storm hits it. But that's not all. This is what lightning sounds like on Earth from space as detected by spacecraft above Earth's ionosphere. They're called whistlers. What you just heard is an actual gust of wind on the surface of Mars. In February 2021, NASA's Perseverance rover recorded this very first sound from the surface of the planet. And NASA's InSight spacecraft recorded vibrations translated to sound that could be a Marsquake. Perseverance just recorded the Ingenuity Mars helicopter in flight. The rover's microphones picked up the low rumble of wind blowing across Mars's Jezero crater just before Ingenuity lifted off, and you can hear the helicopter's blades spinning, producing a higher hum. The incredibly eerie sound you just heard was the Juno spacecraft entering Jupiter's magnetosphere and crossing the gas planet's bow shock. And beware the weird radio emissions the Galileo spacecraft picked up from Jupiter's largest moon, Ganymede. Voyager 2 also recorded the strong electromagnetic pulse from lightning on Jupiter. And now, get ready to listen to the eerie sounds of Jupiter's auroras. These are the haunting sounds as recorded by the Cassini spacecraft, showing a surprisingly powerful interaction of plasma waves moving from Saturn to its moon Enceladus. But that's not all. The spacecraft also picked up intense radio emissions closely related to the auroras near the poles of Saturn. And this is another sample of ghostly radio emissions from the planet. This is the sound of the electromagnetic waves coming from the gas giant Uranus, as recorded by the Voyager 2 spacecraft's plasma wave antenna. This is the real-life, raw, untouched sound of plasma waves as recorded by Voyager 2 during the flyby of Neptune. Voyager 2 has since left our solar system, but before it left, it recorded interstellar plasma sounds. We now have spacecraft out in space that are listening to everything. Ancient people only knew as much about our sun as they could see with the naked eye. Today, we have telescopes and other technology that help us make better observations. But what if we could investigate our sun up close? Recently, scientists have designed and launched a probe on its first in human history journey to the sun. So how close did a spacecraft get? What did it find? And why didn't it melt? Get ready to discover this and some other mysteries of our neighboring star. Without the sun, no life on Earth would be possible. But this gigantic ball of hot plasma can also threaten us. Its bursts of radiation, also known as solar flares, and its explosive ejections of plasma called coronal mass ejections, accompanied by intense magnetic fields, can be frightening. Even though the sun's activity causes spectacular auroras on Earth, spacecraft, satellites, high-flying airplanes, and even astronauts can be in danger. Because of solar storms, our telecommunications, navigation systems, and power grids can fail to properly operate. We haven't been able to understand the sun and how it works, or when it's going to throw a massive ball of fiery plasma our way. This is why scientists have long dreamed of studying our star from a close distance. We know that the solar wind is a constant stream of charged particles that gains enough speed to escape the sun's outermost layer, the corona. But we don't know how energy and heat move through the corona and what accelerates solar energetic particles. Astronomers have been seeking the answers to these questions for 50 years, but to no avail. Finding answers meant sending a spacecraft through the corona that reaches about 1.1 million degrees Celsius. and it seemed impossible to accomplish until recently. This is what the Parker Solar Probe was made for, and it's truly a marvel of human technology. In 2018, NASA has successfully launched the Parker Solar Probe to revolutionize our understanding of the Sun and space weather. The Parker Solar Probe was designed to become the first spacecraft to enter the Sun's atmosphere. It's the size of a small car, and it weighs 685 kilograms. The spacecraft has several important instruments on board. The Solar Wind Electrons, Alphas and Protons Investigation, or SWEEP, will sample particles in the solar wind. The instrument has 4 sensors that calculate the abundance of particles. The Wide Field Imager for Solar Probe Plus, or WISPR, is a telescope that can take 3D images of our star's corona and any structures that pass by the probe. Another tool that Parker is equipped with is called Integrated Science Investigation of the Sun. It's made of 2 separate instruments, each having a different energy range. The instrument can weigh highly energetic heavy ions, electrons, and protons moving through the Sun's atmosphere. Lastly, made of magnetometers and electric field antennas, the Parker Solar Probe will use Electromagnetic Fields Investigation tool to analyze magnetic fields, radio emissions, and density of the Sun's corona. But how can the Parker Solar Probe get so close to our star without melting? To study the Sun under such extreme conditions, the probe and its instruments are equipped with a super reflective coating and a shield that measures 2.3 meters in diameter facing the Sun. The shield, called the Thermal Protection System, is made of 11.5 centimeters of thick carbon composite. This makes the Parker Solar Probe capable of withstanding temperatures outside the spacecraft that reach roughly 1,370 degrees Celsius. And even though that might not seem like enough protection, the density of the Sun's corona isn't high, and not many particles actually hit the probe. The spacecraft and its instruments are also strategically placed in the center of the shadow that's coming from the shield. The Parker Solar Probe also has sensors to let it know that the heat shield has been adjusted when needed. Another level of protection is located on the inside of the probe. Parker has a dual array of solar panels and a smart cooling system. The cooling system circulates water behind the solar cells where it gets heated. Then this same water is pushed down into the radiators where it's cooled. All this makes the Parker probe resistant to heat and radiation like no other space probe before it. And even with that level of protection and low density of the corona, Parker can only stay in this layer of the Sun for a few hours. But how in the world is it possible to even send a probe towards the Sun? It's 150 million kilometers away and would take forever to get there. Reaching the Sun isn't that simple. When a spacecraft is launched into space, whatever velocity rockets give it will be superimposed on top of Earth's orbital velocity, meaning that we can either cause the spacecraft to have more or less orbital energy than the Earth does. We can either boost it to a higher, less tightly bound orbit with respect to the Sun, or deboost it to a lower, more tightly bound orbit. Most of our space probe missions use planetary gravity to accelerate spacecraft and give them more orbital energy. But with Parker, scientists needed to do the opposite, make it lose orbital energy. The Parker Solar Probe has used multiple slingshot orbits using Earth, Mercury, and mostly Venus to enable it to get this close to the Sun. And each time it goes around the Sun, the probe picks up an insane amount of speed. Astronomers call it gravity assist, and it helps Parker narrow its orbit around the Sun and bring its perihelion about 6.4 kilometers closer. So, did it actually touch the Sun? Unlike Earth and some other planets, the Sun doesn't have a solid surface, but it still has a boundary. The point where the Sun's gravity and its magnetic forces keep in the solar material is called the Alfvén critical surface. According to astronomers' calculations, it should be anywhere between 10 to 20 solar radii from the surface of the Sun, which is roughly 7 to 13.8 million kilometers, and scientists believe that it marks our star's boundary. With every gravitational maneuver, the spacecraft narrowed its distance to the Sun, and as it did so, astronomers searched for signs that the Parker Solar Probe had reached the critical surface. So what happened when NASA's spacecraft arrived at its destination? As the probe passed through a pseudo-streamer or a loop-like structure in the corona of the star, the whirlwind of particles started moving much slower, limiting the impact on the probe. This meant that the magnetic fields were dominant in that region so that no particles could escape it. It was the proof that the Parker was inside the Alfvén critical surface. The spacecraft then recorded a video of coronal streamers moving past it. It was the first time scientists were able to see these mysterious objects from up close. The data collected from the probe shows that switchbacks or zigzag structures in the solar wind are quite abundant close to our star. Before, astronomers thought these zigzag structures were rather an abnormality occurring near the sun's poles only. But the spacecraft helped scientists conclude that these structures originate in the solar surface and are quite common. Parker has also discovered that the critical surface was 18.8 solar radii from the solar surface, and it took 8 flybys and over 3 years to finally get there. But this wasn't the only discovery made by Parker that fascinated scientists. Multiple flybys near Venus have opened more opportunities to study this hot world. Until recently, astronomers didn't know exactly what the planet's surface looked like. Usually it's covered with thick clouds, so a big part of the visible light coming from the surface of Venus is shrouded from sight. Parker didn't only manage to record the atmosphere of our Sun, but it also captured Venus's surface from space. During its flybys, Parker used its wide-field camera to take images of the entire night side in wavelengths of the visible spectrum. For the first time, scientists were seeing Venus's surface in visible wavelengths from space. Even on the night side, the surface of the planet is roughly 475 degrees Celsius. It's so hot that you could see its rocky surface glowing. So far, the spacecraft has approached the Sun at a distance of 8.5 million kilometers from its surface. The previous record was set by the Helios 2 spacecraft in 1976, and the distance was only about 43.5 million kilometers. Aside from that, Parker is also breaking space speed records. During one of its approaches, it was moving at about 700,000 kilometers per hour. At that speed, it would take Parker about 1 second to get from Philadelphia to Washington, D.C., or less than a minute from New York to Tokyo. This makes it the fastest human object ever made. Scientists haven't found answers to all their questions yet, but as the spacecraft enters the Sun's atmosphere again and again, we'll find more clues. The Sun has an 11-year activity cycle during which its stormy behavior intensifies and then settles back down to a minimum. And because it currently ramps up, its corona will expand, giving the Parker probe even more opportunities to enter it again and stay in there for a bit longer. Eventually, the spacecraft will get as close as 6.1 million kilometers from the Sun's surface. This is just within the orbit of Mercury, which is roughly 7 times closer than any spacecraft has ever approached the Sun before. The Parker Solar Probe hasn't finished its mission yet. NASA wants to send the spacecraft deeper into the solar atmosphere to collect more data about how our neighboring star works. It'll help better understand the phenomena happening inside and around the Sun. The Sun is the only star we can study from such a close distance and the only one known to us that can support life. So if we understand it well enough, we can succeed at searching for life outside our solar system. Eventually, the probe and its instruments will start failing, and the spacecraft will melt into a charred piece of metal that'll keep orbiting the big glowing ball of hot plasma. Its journey will come to an end, but until then, it could surprise us with more fascinating discoveries. The Earth was formed from a solar nebula about 4.5 billion years ago, weighs 5,972 yotograms, and its radius is 6,371 kilometers. The numbers are so impressive that it seems that scientists have studied absolutely everything about our planet. But this is far from the case. We know a lot about what is on the surface of the Earth, but what is under the crust only raises questions. And to find answers to them, scientists go to any methods. What ancient planet is hidden inside ours? What sounds have scientists heard under the Earth's crust? And why did the deepest journey into the Earth stop? So, first things first. Our Earth consists of 3 main layers. The very first is the crust. This is the outermost layer of the planet. Its depth ranges from 5 to 75 kilometers. The thickest layers of the crust are on the continents, and the thinnest at the bottom of the oceans. The Earth's crust is made up of plates that constantly move at the rate at which our fingernails grow. This movement is due to the mantle, the next layer of the Earth. The depth of the mantle is about 2,890 kilometers. This layer consists of silicate rocks heated to temperatures of 900 degrees Celsius near the crust and up to 4,000 at a depth. When this incandescent substance bursts upward, volcanic eruptions occur. The last layer of the planet is the most mysterious. This is the core, the heart of our Earth. The radius of the core is about 2,180 kilometers. The inner core is solid and presumably composed of iron. The outer is liquid and consists of an alloy of nickel and iron. Also, the inner core rotates at a different speed than our planet. To study the secrets of the inner layers of our planet, scientists regularly take various measurements. During one such seismic tomography of our planet, scientists discovered something strange, namely the mysterious lumps floating inside the Earth's mantle. Some of these lumps combine to form large-scale regions. The two of the largest are located under Africa and under the Pacific Ocean. But something else is interesting. They don't just float harmlessly in the mantle of the planet, but create a unique anomaly. In particular, we're talking about the South African anomaly, which weakens the magnetic field of our planet. Serious changes in the magnetic field can lead to catastrophic consequences, up to a change in the poles. But the discovered anomaly, fortunately, is not so strong yet. However, what is the nature of its occurrence? And what are these mysterious clots that give rise to it? The mysterious substances are called LLSVPs, stands for Large Low Shear Velocity Provinces. They've existed for a huge amount of time, long before life appeared on Earth, and many scientists suggest that these are the remains of another ancient planet, which the Earth once collided with. According to this hypothesis, the planet Theia, which was similar in size to Mars, moved in a spiral trajectory through the solar system. It's impossible to calculate how fast the ancient protoplanet moved, however, our Earth became its final stop. If Theia hit the Earth at a right angle or too sharp an angle, it would be a disaster, which most likely would entail the destruction of our planet. However, Theia hit the target perfectly at a 45-degree angle. Thanks to this, our planet withstood, and just a piece broke off from it. Theia plunged deeply into our planet, and as a result, its core merged with the core of the Earth. After this collision, our planet received a sharp increase in rotation speed, 1 revolution in 5 hours, and a noticeable tilt of the rotation axis. Thanks to this, we got a change of seasons and a 24-hour day. A powerful split of the Earth's surface occurred, provoking a chemical exchange. This allowed the emergence and development of life on our planet in new conditions. That is, it is quite possible that it was thanks to the collision with Theia that humanity eventually emerged. In return of this gift, Theia chipped off a piece of Earth and took its place. But where did this mass thrown out of the planet go? If you look out the window in the middle of the night, you'll see the answer. Many scientists are confident that the Moon was part of our planet in the past and separated after the collision of Earth with Theia. The theory is supported by another amazing discovery that humanity made several decades ago. For this, let's go back in time to the late 1960s. The Soviet Union was not the only country that was first to send a person into space, but also the first to travel into the interior of the planet. For this, a large-scale project was created to drill the deepest well on Earth. It was named the Kola Super Deep Borehole SG-3. The initiator of the project was David Guberman, who devoted most of his life to the project. The drilling work progressed with great enthusiasm. It was possible to drill up to 4 meters per day, depending on the density of the rocks. 8 hours were spent on the lowering of the drilling tool, another 8 on the drilling process itself, and the remaining 8 for extraction of the rocks. Drilling proceeded relatively calmly down to 7,000 meters. Scientists did not encounter any difficulties, and the drill went through homogeneous solid granites. However, after a depth of 7,000 meters, the drill head entered the less durable bedrock. Regular accidents began to occur. However, scientists continued to work, and by 1983, the mark of 12,066 meters was reached. The project was put on a short pause. Immediately after the resumption of work, a terrible accident happened. The the drill string broke off. Scientists were thrown back 5 years and continued to work from a depth of 7,000 kilometers. This mark turned out to be fatal for the project. Whenever scientists approached a depth of 12 kilometers, strange accidents occurred, and they had to start again from a depth of 7,000. According to scientists, it was almost impossible to work at a depth of 12 kilometers. The temperature rose above 200 degrees, and the resources of the equipment at that time were not enough. The deepest mark that scientists have been able to descend was 12,262 meters. In 1994, after another accident, the well was closed. The scientists who directed the experiment consider it to be incomplete. After all, the main goal was to reach the mark of 15 kilometers. It was assumed that after this depth, the drilling rig would be able to get to the Earth's mantle. If this project was completed, these discoveries could literally flip over all ideas about the structure of our planet, but they couldn't get through the last 3 kilometers. The Soviet Union collapsed, the project was no longer funded, and now the well is sealed with a strong iron hatch, according to David Guberman himself, so that curious stalkers do not throw stones into the well. However, it cannot be said that the experiment really failed. During their work, scientists managed to obtain a huge number of samples of the Earth from different depths to confirm several theories about the hydrodynamic zonal model of the Earth's crust, and also to make 2 amazing discoveries that are especially interesting to us. The first was overgrown with legends even before it actually happened. The Kola experiment was widely reported in the press, and one day, a Finnish newspaper published the news on April the 1st that the purpose of the well was to find the entrance to hell. This humorous news was immediately picked up by American newspapers, which began to talk about it in all seriousness. As a result, a legend has spread over the planet that when the well was drilled to a depth of 14.5 kilometers, they suddenly came out into some huge empty space. The temperature in this space reached 1100 degrees. Having lowered the microphone to this depth, the scientists recorded heart-rending human screams. American newspapers called it the screams of sinners tortured in the underworld, and years later, a supposedly real recording captured by microphones from that depth spread across the network. In fact, the story is the purest invention of a Finnish journalist, which the American media trustingly fell for. But we would not talk about this case if not for another mysterious situation that's associated with sounds. Here is a direct quote from academician Guberman himself, who supervised the experiment. When I'm asked about this mysterious story, I don't know what to answer. On the one hand, the stories about the demon are rubbish. On the other hand, as an honest scientist, I cannot say that I know exactly what happened here. Indeed, a very strange noise was recorded. Then there was an explosion. A few days later, nothing of the kind was found at the same depth. But another discovery has amazed the scientific part of society. As already mentioned, soil materials were regularly lifted from the depth of the well. Of particular interest were the samples raised from the depth of about 3 kilometers. After a thorough study of these materials, it turned out that they almost completely coincide with the materials of the soil brought by the American cosmonauts from the moon. Thus, the theory that the moon is part of the Earth, which broke away after a collision with Theia, became even more likely to be true. And these are far from all the discoveries that were made thanks to the Kola well. An analysis of the methods of its ultra-deep drilling helped several years ago to discover the real ocean of the Archean period by Russian, French, and German scientists at a depth of 410 to 660 kilometers below the Earth. A huge body of water is located under the Earth's crust and was formed under conditions of high pressure and temperatures of 1530 degrees Celsius. The water in it is enclosed in the crystalline structure of minerals. And now, we cannot even guess whether these minerals contain any living organisms inside them. In order to find the answer to this question, you'll have to take another trip to the center of the Earth. But unfortunately, even if such a project is planned, there's no data on it yet. Therefore, for now, we can only find more and more questions to which there are no answers. But make sure to stay tuned here, and we'll let you know when we find more answers to this and other incredible mysteries of our planet and the universe around us. In 1977, Voyager 1 and Voyager 2 launched from Cape Canaveral less than a month apart. By the way, Voyager 2 launched earlier, but since it had a different flight path, it flew to the edge of our solar system second, 6 years after its colleague. Both devices found a very strange anomaly. As you move away from the Sun, the density of space increases. Interstellar space is usually considered a vacuum, but this is not entirely true. The density of matter is extremely low, but it still exists. In the solar system, the solar wind has an average density of protons and electrons of 3 to 10 particles per cubic centimeter, but it's lower the farther from the Sun. The smallest density of space is at the edge of the solar system. This boundary is called the heliopause. On it, the speed of the solar wind, the flow of charged particles emitted by the Sun, or in other words, solar plasma, drops to zero. The area between the Sun and the heliopause is called the heliosphere. This is a kind of bubble in which all the planets of the solar system are immersed. At this boundary, the density of protons and electrons is 0.002 particles per cubic centimeter. According to calculations, the density of particles behind the heliopause, that is, in interstellar space, should be 0.037 particles per cubic centimeter. The Voyager 2 instrument showed that the density outside the solar system, at a distance of 119.7 astronomical units or 17.9 billion kilometers from the Sun, was 0.039 particles per cubic centimeter. This almost coincided with the calculations, but then the strangeness began. At a distance of 124.2 astronomical units or 18.5 billion kilometers, the density was 0.12 particles per cubic centimeter. Why is the density increasing? We'll definitely talk about this a little later, but for now, let's talk about another bubble, much larger than the heliosphere, so that you'll appreciate all the thoughtfulness of the cosmos that packed us into two bubbles at once and understand the relationship between them. When you look at the pictures of deep space, you get the impression that it's filled with clouds of interstellar dust and luminous gas. But back in the 70s and 80s of the last century, astronomers began to pay attention to the fact that the galactic space around the Sun differs from this picture. The solar system seemed to hang in an almost absolute void. This year, scientists at the Harvard-Smithsonian Center for Astrophysics, CFA, proved that yes, we really are in a kind of void. They conducted the most complex computer simulations, creating a three-dimensional reconstruction of space and time. The study showed that the Sun and Earth are located almost in the center of a giant bubble with a diameter of 1,000 light-years, which they called the local bubble. According to calculations, it began to form about 14 million years ago. For this, it's necessary that about 15 supernovae explode over several million years. This series of explosions pushed the interstellar gas outward with the pressure of light, creating a bubble-like structure with a dense surface at the boundary. And now, the bubble continues to grow in size. When the bubble first formed, it was expanding at about 60 miles per second. According to data collected by the European Space Agency's Gaia Space Observatory. At present, the bubble is still expanding at 4 miles per second. On its surface, 7 star formation regions were detected, dense molecular clouds where stars are formed. The process of star formation occurs everywhere on the surface of the local bubble, and there are many such bubbles in the galaxy. Therefore, it's possible that there are other stars, even with planets, which, like us, are also in their local bubbles. Interestingly, the Sun was not at the center of our universe at first. When these catastrophic explosions occurred, the Sun was far away from the scene, about 1,000 light-years away. But, as João Alves, an astrophysicist at the University of Vienna, explained, about 5 million years ago, as it orbited the center of the galaxy, the Sun got almost right at the center of the bubble. This is consistent with estimates of radioactive iron isotope deposits from a supernova in the Earth's crust from other studies. The researchers suggest that there are probably more star formation bubbles in the Milky Way. Research author and astronomer of CFA, Elisa Goodman, who founded GLUE, explains in her statement that, statistically, the Sun would not be near the middle of a huge bubble if they weren't spread all over the place. The local bubble is exactly the bubble we're in right now, she said. We think the Sun has probably gone through a lot of superbubbles in its history. The scientists compared the cosmos with Swiss cheese. The holes in the cosmos are punched out by supernova explosions, and new stars are being formed on the edge of the holes created by dying stars. The research team plans to map more cosmic Imagine two streams colliding head-on at cosmic speeds. Of course, at the point of collision, the density increases. It's like a traffic jam, a chaos of particles. And behind this jam, at a distance of 0.75 to 1.5 light-years, the Oort cloud spreads, a spherical cloud of ice objects up to 1 trillion, which serves as a source of long-period comets. The interstellar wind already dominates here, but the Sun is still holding bodies in its gravitational field with its last strength. Of course, many of our viewers may ask the question, well, we're in a bubble that's huge by earthly standards, even in a double bubble, local and heliosphere. Well, so what? How does this affect our lives? About that small bubble, the heliosphere, we can say unambiguously that thanks to it, thanks to the traffic jam that formed on its border, the Earth is reliably protected from high-energy cosmic particles rushing from the center of the galaxy. Now for the local bubble. Scientists have long found out that our galaxy, the Milky Way, has the shape of a spiral disk. Several spirals diverge from its center, which astronomers call arms. Right now, our Sun is almost halfway between the Sagittarius arm and the Perseus arm. And our Sun revolves around the center of the galaxy. It makes one revolution in 200 million years. We call this a galactic year. Only 0.0008 of this year has passed since the appearance of man. In its path, the Sun, with all its planets, crossed not only bubbles, but also accumulations of interstellar gas, when the density of matter in space jumped hundreds of times. Astrophysicist Miroslav Filipovich, using the latest model of the Milky Way, checked what happened on Earth when the Sun crossed the galactic arms in which the density of interstellar space is much higher. A relationship has been found between the time the Sun crossed the spiral arms and 5 known mass extinction events: 415, 322, 300, 145, and 33 million years ago. So we can assume that now the Sun is in a quiet harbor, favorable for all living things. And we can say that humanity is very lucky that we appeared on Earth as a species when the Sun flew into the local bubble before that. Or maybe these two events are somehow connected: the appearance of man and the presence of the Sun in a safe haven, the local bubble. Science has no information about it, at least not yet. But we can definitely say that we observe such a colorful sky above our heads only due to the fact that we're practically in a void, the local bubble. If the space around us was denser, many stars would be invisible. And who knows if we would know about space and about the structure of the universe as much as now if we were literally in the dark. And we can say that the local bubble is just a gift to humanity, which has entered the space age and is already trying to jump to the stars. For an interstellar craft moving at subliminal speeds, the greatest threat is dust particles, which will simply grind the ship to powder during collisions. Even hypothetical concepts such as ships imply a frontal shield. But now, it turns out that the cosmos seems to have taken care of us. It removed the dust in the vicinity of the Sun and, as it were, says, "Forward, guys, the path to Alpha Centauri and Tau Ceti is open." Scientists have been studying planets for a long time now, and it's not that difficult to get samples of our planet, the Moon, and even Mars. But how do you get information about what a planet's made of that you can't reach? To find out what a celestial body is made of, scientists use many techniques. They combine the information about a planet's density, seismic activity, magnetic field, and so on. But one method is specifically interesting. It's called remote sensing, or spectroscopy, and it involves using light. The process includes using instruments with a grating that spreads out the light from an object by wavelength. The thing is, each element has its own peculiar fingerprint. Scientists then identify this fingerprint in the spectrum of a certain object and can tell what it's made of. So, what have we learned about our solar system so far? As of now, we know for sure what our Sun is made of, including its chemical composition and its internal structure that consists of layers. It all begins at the core of the Sun, or its central part, the place where all the thermonuclear processes happen. The radius of the Sun's core is more than 150,000 kilometers, and it's extremely hot, over 15 million degrees Celsius. By comparison, it's only about 5,500 degrees Celsius on the surface of the Sun. So most of the energy and heat that keeps our solar system warm is generated within that core. But what is it made of? Scientists think that it consists of 64% helium, 35% hydrogen. But if we take the Sun in general, roughly 91% of it is helium. More than 8% is hydrogen, and the remaining elements are pure iron, silicon, oxygen and nitrogen, sulfur and magnesium, and some others. The core of the Sun is surrounded by the radiative zone. It's called this because of the way in which the energy of the Sun radiates to its surface. This region starts about 25% of the distance to the surface and stretches up to approximately 70% into the depth of the star. This is surrounded by the convection zone, or the last layer of the solar interior. This thick layer of the Sun is about 200,000 kilometers deep. Its main function is to transport energy to the surface of the Sun. Hot plasma inside this region churns vigorously, similar to hot lava from a volcano. When it finally reaches the surface, it gives off heat, cools down, and goes back to the bottom of the convection zone. But that's just the internal structure of the Sun. Our yellow dwarf also has a solar atmosphere and outer layers: the photosphere, chromosphere, transition region, and corona. The photosphere is the visible part of the Sun, and it's about 200 kilometers thick. It's this layer that sends the Sun's rays into space. Looking deeper, you'll find the chromosphere, which is much larger, up to 2,000 kilometers thick. In the chromosphere, there's a constant movement of gases. This is where filaments, which are large regions of very dense, cool gas, held in place by magnetic fields, can leap off the surface of the Sun. Sometimes these filaments travel beyond the surface of the Sun up to 250,000 kilometers, and sometimes even overcome solar gravity and break off into space. The next layer is just a few tens of kilometers thick, called the transition region. This is where our Sun becomes very hot. The last outermost part of our star's atmosphere is the corona. From Earth, this layer looks like a radiant halo surrounding the solar disk. The gas here is heated to more than 1 million degrees Celsius. At this temperature, the most common chemical elements, hydrogen and helium, are completely ionized. In other words, they lose all their electrons and stop producing spectral lines of radiation. And therefore, in the visible range of the spectrum of the solar corona, completely different elements begin to dominate. such as highly ionized atoms of iron and calcium. Not so long ago, NASA's Parker probe entered our Sun's outer layer, becoming the first human spacecraft to touch the Sun. If you want to see a video of how it managed to do this and not melt, tell us in the comment. Called superrotation. The next layer is the mantle. Its thickness is about 2,900 kilometers. The mantle makes up an astonishing 84% of our planet's total volume. This layer consists of silicate rocks heated to roughly 1,000 degrees Celsius near the crust and up to 3,700 degrees Celsius at its depth. Whenever this red-hot substance bursts upward, volcanic eruptions occur. The third and last layer is the crust, the outer layer of our planet. Its depth extends for 5 to 70 kilometers. The thickest layer of the crust can be found on the continents, while the thinnest ones are at the bottom of the oceans. Mars. Moving farther away from the Sun, you'll find the Red Planet, which has attracted the attention of scientists since ancient times. Not so long ago, scientists were able to collect precise data about the planet's structure thanks to the probe InSight. The probe measured about 733 Marsquakes and used the information from 35 of them to form a picture of the Martian crust, mantle, and core. scientists discovered that Mars consists of 3 layers. The deepest is the core. It occupies about half the radius of Mars, about 1,800 kilometers. The total radius of Mars is roughly 3,400 kilometers. Research data shows that the core is liquid, although its large size indicates that it's less dense than previously thought. This means that the core likely contains lighter elements such as sulfur, oxygen, carbon, and hydrogen, in addition to iron and nickel. The next layer of Mars is the mantle. It has an upper, middle, and possibly lower part. The mantle of Mars consists of a single layer of rock, with a solid lithosphere extending for 700 to 800 kilometers. To compare, the Earth's lithosphere is only about 100 kilometers thick. However, both lithospheres likely have a lower region, where material begins to melt and move slowly. The existence of the lower mantle has not been reliably established yet. Similar to our planet, the outer layer of Mars is the crust. The thickness of the red planet's crust is 24 to 72 kilometers. It's also approximately 4.4% of the total Mars volume. Surprisingly, the crust also consists of 2 layers. The uppermost layer turned out to be unexpectedly porous, and the crust was thin. This points to a high proportion of radioactive elements in the planet's crust. Jupiter. Let's move on to the largest planet in the solar system, Jupiter. Its dimensions are colossal. The equatorial diameter is roughly 140,000 kilometers. The polar one is somewhat smaller, about 130,000 kilometers. You could fit 1,300 Earths inside Jupiter. But at the same time, the actual mass of Jupiter is only 318 Earth masses. The difference in the volumes and masses of Jupiter and the Earth means they differ in average density and differ in internal structure. Low density indicates that the planet consists mainly of light components, hydrogen and helium. Scientists think that heavy elements in the interior of Jupiter account for about 20 Earth masses, or 6% of the total mass of Jupiter. Probe Galileo showed that the structure of the upper atmosphere of the planet consists of 75% of hydrogen and 24% of helium, and the other components are just 1%. As of now, researchers believe that the planet has a solid metal silicate core. One theory is that the core could be surrounded by a shell of hot water, methane, and ammonia in the gas-liquid state under enormous pressure of about 38 million bar. The very same diameter of the core of Jupiter, together with its shell, is 32,000 kilometers. After the core is a layer of metallic hydrogen. The thickness of this layer is approximately 40,000 kilometers. At enormous pressures and temperatures, the electrons in hydrogen atoms break away from the nuclei. The same happens with metals in which electrons move freely. That's why the layer is called metal. After that comes the lower layer, consisting of hydrogen, helium, and mixes of ammonia, ammonium hydrosulfide, and water, which forms 3 layers of clouds. The lower layer is water ice, and possibly liquid water. Its temperature is approximately minus 130 degrees Celsius. Above that, there are clouds of crystals of ammonium hydrosulfide, and the top one is filled with clouds of icy ammonia. But that's not all. Even higher, there's the middle layer of Jupiter, made of 90% hydrogen and 10% helium. And the last outer layer is made of hydrogen only. This is why scientists see Jupiter as a compact, solid metal silicate core, surrounded by a gas-liquid and gaseous hydrogen-helium shell, which can be called the planet's atmosphere. And Jupiter doesn't have a solid surface. Gases transform to liquid state and from liquid to solid state gradually over the gigantic radius of the planet, exceeding 70,000 kilometers. But Jupiter is also famous for one other interesting thing. Because of the extreme pressures and temperatures in its atmosphere, hydrogen gas compresses into a liquid. So the planet has the largest ocean in the entire solar system, but filled with hydrogen instead of water. Saturn. The structure of Saturn is very similar to the structure of its neighbor. However, there are still some differences. At the center of the planet is a massive core of solid and heavy materials, silicates, metals, and possibly ice. The mass of the core is about 17 Earth masses. The core temperature reaches at least 24,000 degrees Celsius. This is hotter than the surface of our star. What's even more interesting is that the energy that Saturn's core radiates into space is 2.5 times the energy that it receives from the Sun. Saturn is the least dense of all the planets in our solar system. Its density is less than that of water. What this means is that if space was filled with water, Saturn would float. On the cosmic scale, the rings of Saturn are very thin, about 1.5 kilometers, and their diameter is approximately 250,000 kilometers. Despite their impressive appearance, there are very few substances in these rings. If they were compressed into one body, they would be no more than 100 kilometers in diameter. The particles of these rings are composed of water ice, which, in its turn, consists of solid rock particles frozen into the ice. Uranus. The next planet after Saturn is Uranus. Similar to its neighbor, this planet also has a solid core, which consists mainly of silicate rocks. However, the core of Uranus is larger than that of Saturn or Jupiter. The temperature in the center of Uranus can reach at least 9,000 degrees Celsius. The core is surrounded by a shell of rocks and ice. Above that, there's a 1,000-kilometer layer of liquid nitrogen, gradually turning into gaseous molecular hydrogen. But some scientists think that Uranus does not have a solid core, and at a distance of about 1/3 of its radius from the center, there's metallic hydrogen. The rotation of this planet creates flows of hydrogen that give rise to an electric current. This is where the planet gets its magnetic field from. Uranus has a faint ring system made up of very dark particles ranging in diameter from micrometers to fractions of a meter. These rings consist mainly of microparticles and a small amount of dust. Neptune. The last planet in the solar system is Neptune. Neptune is the 4th largest planet by diameter and the 3rd largest by mass. Its mass is 17 times greater than that of the Earth, while its diameter is almost 4 times greater than our planet. Neptune's structure is similar to Uranus's. Its core is made of iron, nickel, and silicate rocks. The pressure in the planet's center reaches 7 megabars, which is about 7 million times more than on the surface of the Earth. Above Neptune's core, there's the planet's mantle. The mantle of Neptune is rich in water, ammonia, methane, and other compounds. And although this matter is called icy, it's actually a hot and very dense liquid. The farther you get from the core, the more Neptune's surface develops into a darker and hotter atmosphere. It makes up approximately 5 to 10% of the total mass of the planet. The temperature on Neptune in the upper atmosphere is close to minus 200 degrees Celsius. At first sight, Neptune is quite bland compared to the breathtaking Saturn or mighty Jupiter. But there's something about this planet that makes it stand out. Beneath the outer layer of Neptune hides a constant rain of diamonds. Because of the temperatures and high pressure of the planet, methane molecules break apart and release carbon, which forms into chains. and it is these chains that squeeze together, harden, and form patterns of crystal structure resembling diamonds. And because the outermost layers of the mantle are way cooler than the lower layers, as those diamond stones fall, they start heating up and turn into liquid. Then the entire cycle repeats. We told you about the internal structure of the main objects of the solar system, but what did we miss? Tell us in the comments, and subscribe to the channel to stay updated on exciting videos about space.